today we will have the practical of surveying, for which we have to use the instrument thedolite. So we will see the title and aim of our practical. So our title of practical is measurement of horizontal angle by using repetition method, and aim of this practical is to measure the horizontal angle between two different points. So we will see different components of thedolite. So before that I will just explain you what is exactly the repetition method. So suppose on ground this is our point A, that is station A. At this point we have fixed our instrument and we have to take the readings between point A and B. So the angle between this point A and B will be denoted as theta, and in this repetition method we have to observe the readings of these different points repeatedly with two face left and face right conditions. So in this figure, suppose this is your point A and this one is your point B. So after observing theta 1, again you have to rotate instrument, again you have to take the reading, that is theta 2, again you have to rotate the instrument, again you have to take the reading theta 3, and then at the last you have to take the average of these three readings, and that will be your angle in between 2 points, which is found by using the method of repetition. So now we will see the detailed components parts of this thedolite. So I have this thedolite with me. The least count of this thedolite is 20 seconds. So we will see the parts of this thedolite from bottom. Now at the bottom you can see 3 foot screws are provided for this thedolite. So these 3 foot screws are fixed to this base plate, and this portion of this foot screw and base plate is known as the leveling head. So use of these foot screws is for leveling of the instrument. So you can have the movement of these foot screws in the clockwise direction or in the anti-clockwise direction depending upon the setting of your grounds. So first you have to place your telescope parallel to these 2 foot screws, then you can rotate your foot screws in inner side or in the outer side. Then you have to place this telescope perpendicular to that 2 foot screws, and then you can rotate the remaining foot screws in clockwise direction or in anti-clockwise direction. Then above this base plate we are having the level tube for observing the level of our instrument. So while doing the leveling you have to check that this bubble must be in the center before starting your practical. So this is one level tube and this one is another level tube. One level tube is fixed with the vertical circle. So this is vertical circle, this one is, and one level tube is fixed with the horizontal circle. So you have to take care of this both bubble tubes and make sure that these both bubbles are present in the center of your instrument. After leveling of this instrument, you have to mark your center point on the ground. So marking of your center point can be seen by using this center point knob. So by observing the reading from this point, you can see that your center is marked on the ground. So by using plumb bob you can mark your center, and you can make sure that that marking coincides with your instrument's marking. So this point is used for the centering. Then our instrument is provided with the 2 clamp screws. So for this base plate we are having the upper clamp and we are having the lower clamp screws. So these are now both screws are loose in condition. So by this one you can observe that instrument is freely moving. So this free movement of instrument will be happen whenever your low clamp is free. And once you tight this your low clamp screw, then now you can see that only the upper part of instrument is moving. So that is the basic difference. So whenever you have to take the reading, you make sure that your low clamp screw is tightened. For adjusting this lower clamp screw, we are having this lower clamp adjustment screw also. Now once I tight this upper clamp, then you can see that the instrument is not moving from its space. So the use of this upper clamp is for what? To fix the reading, to fix the instrument. So once you will lose this lower and upper clamp, then your instrument will be freely moving. Now use of these screws is for adjustment of 2 vertical scales or horizontal scales which are available with this instrument. So this instrument is provided with the 2 scales. One scale is vernier and one is the main scale, and also it is written there vernier A and vernier B. So on the both sides you can see that by using this mirror you can observe the readings which are available on that thedolite. So this mirror is provided again with the adjustment. You can adjust your eyesight and you can observe the reading. Then on the top of this thedolite portion you can see that vertical circle is provided. So this vertical circle is used for measurement of vertical angle. So whenever we are dealing with the vertical angle, we have to use this vertical scale for measurement of angle. For adjusting this vertical circle we are having this upper clamp. So once you lower this upper clamp, then your telescope will be moving from upward direction to the downward direction, and once I tighten this upper clamp, vertical clamp screw, then your thedolite is telescope is fixed in its position. For observing the readings for this vertical circle, we are having two verniers, that is vernier C and vernier D. So at the bottom we are having A and B, at the top you are having C and D. Now whenever you are taking the readings by using this thedolite for this repetition method, then you have to take the readings by using two different phase condition. So once when you take the reading, when this vertical circle is at your left hand side, then this position is called as the phase left condition. So whenever the vertical circle is available at the left side of the observers, then that condition is known as the phase left condition. And whenever you are taking the readings with this vertical circle on the right hand side of the observer, then this condition is known as the phase right condition. So in repetition method you have to take 3 readings by using phase left condition and 3 readings by using phase right condition. And when this telescope is inverted, now this telescope is in its original position, so this is the normal condition, and when you are taking the readings with phase right condition, then this will be your inverted telescope. This telescope is again provided with different screws. So this screw is known as the focusing screw. So this screw is used for focusing of our object. Then this eyepiece is provided with the 2 rings. So this ring is again used for observing the diaphragm to clear our vision, to clear the diaphragm. So this side is known as the eye side and this side is known as the object side. So you have to pass one imaginary line from this eye side towards this object side and you have to bisect your object. So these are some basic components which are used in the thedolite. Now this thedolite is having 20-second least count. So we have seen different components of the thedolite. Now we will see vernier scales of the thedolites which are used for measurement of readings. So now in the camera you can see that 2 scales are there. So one is the vernier scale and one is the main scale. So vernier scale is having the readings from 0, 5, 10, 15 and 20 which are seen to you, and the bottom scale, that is the main scale, is having the readings from 210, 220, and these readings, in between these 2 readings you can see there are small lines which are present. So for example, if we take 20 to 5, so in this suppose 20 to 15, so in the 20 to 15 we are having 10 number of lines. So 5 big lines are there and 2 small lines are there. So one small line is giving us the reading of 20 seconds. So least count of this thedolite which we are going to use is 20 seconds. So whenever we will measure the reading, then we can measure the least reading up to 20 seconds. So when we have to take the reading, so you have to make sure that 2 lines which are coincides to each other, that will be our reading. So in this you can see that 2 scales are there. So this is vertical scale which is provided with the thedolite. So in this 2 verniers are there, vernier C and vernier D. So now you are looking at vernier D. So in this again we have markings from 0 to 20. So 0, 5, 10, 15 and 20. But in this vertical scale, what is the big difference? So vernier which is provided is having the markings on both sides. So instead of 0 you can see 20, instead of 5 you can see 15, and 10, 10 is similar. And also the readings which are provided on the main scale are varying from 0 to 90 degree, 0 to 180 degree. So these are the markings which are provided on the vertical scale. So when we are measuring the vertical angle, then we will use this vertical scales, and when we will measure the horizontal angles, then in that case we will use the horizontal
scale, and you have to make sure that you must check the list count of the instrument before taking the readings. Now when you have to observe the reading, then in that case you have to check that the two lines which are coinciding of the vernier and the main scale, that will be your angle only. So now I have set up my instrument at station point O. So before starting the readings, taking the readings, I have make sure that the level tubes, so the level tube which is at bottom and which is at top, the bubble tube is at center. Then all the settings are done by using these 3-foot screws. So before taking the readings, you have to adjust your both verniers for 0 degree and 180 degree. So I have adjusted the vernier A at 0 degree and vernier B as 180 degree. So with the help of lower clamp screw, I have adjusted the readings. So you can take the help of this lower clamp and upper clamp also, and the tangent screws also for taking the readings. So now I will bisect the first point, that is point A. So you can see that two ranging rods are fixed at point A and point B. So we have to measure the angle between these 2 points, that is point A and B. So first step will be, I will lower the lower clamp. So this will be my lower clamp screw. So I will loosen this lower clamp screw and I will bisect the point A. So with the help of this focusing screw and with the help of this eyepiece, I have cleared my diaphragm, I have cleared my views. Now once the object is visible by my eyes, I will just tighten this lower clamp screw which will I have loosened, and if slight change I have to do, then I will use this tangent screw, that is lower tangent screw. Now my object is visible to me. Now I will measure the readings of vernier A and vernier B. So now same readings will be there. So for vernier A, my reading is 0 degree 0 minutes and 0 seconds, and for vernier B, my reading is 180 degree 0 minutes and 0 seconds. So these are both readings which are present. Now we are using here the first left condition. So that's why this vernier circle is present at my left hand side, that is left side of the observers, and I have to measure the reading from point A to point B, and we are going to use the method of repetition. So I will now just loosen the upper clamp. So this is my upper clamp screw. So I will loosen this upper clamp screw. So by losing upper clamp, what happens? The angle is changed. So now I will bisect the point B. So I am moving in the clockwise direction. So I have bisected the point B. I will adjust the focusing screw, I will adjust the eyepiece, and by adjusting both the readings, I will just tighten the lower clamp which I have loosened. Now after tightening this upper clamp screw, I will measure the readings which are present on at verniers A and vernier B. So now we will measure the reading which is present at vernier A. So my reading for vernier A, so the line which coincides for the main line and vernier line is making the angle of 30 degree 15 minutes and 10 seconds. So this is the angle which is present at vernier A. Now I will measure the angle at point B. So at point B, the angle is, so first we have to check which line is coinciding. So at vernier B, my angle is 60 degree 10 minutes and 15 seconds. So these are my both angles at vernier A and vernier B. Now after taking the readings, I will again loosen the lower clamp. So this is my lower clamp. Then I will rotate the instrument in clockwise direction, and then I will bisect again the point A. So after bisecting the point A, I will again tighten my lower clamp screw. So the readings will be same which are the for the previous point. So the reading at vernier A is 30 degree and 10 minutes and 15 seconds, and reading at B will be 60 degree. So yes, it's 60 degree 10 minutes and 15 seconds. Now again I will loosen the lower clamp screw. Again I will move the instrument in the clockwise direction. I will bisect the point B and I will measure the reading. So before measuring the reading, I will just tighten both the screws and we have to measure the reading. So I will just note down the readings at vernier A and B, and again I will follow the same procedure. So again I have to lower the lower clamp screw. So I am shifting the instrument in clockwise direction. Now I will bisect point A again. Now again I will fix this lower clamp screw. So the readings will be same as the previous point. Now after observing the readings which are similar to the previous point, I will loosen the lower clamp screw. After losing the lower clamp screw, I will again move this instrument in the clockwise direction at point B. Now again after bisecting the object, I will tighten the lower clamp and I will measure the reading. So you have to observe the readings at point A and at point B, and after observing the readings you have to write down the readings. So in this method you have to remember that the readings, whenever you are taking the readings at the first point, then always you have to lower the lower clamp screw, and whenever you are taking the readings at point B, then you have to lose the upper clamp screw. So if you lose the upper clamp screw, then the upper part of this theodolite is moving, and due to this the angle is changing. If you loosen the lower clamp screw, then the whole instrument is moving, so you cannot measure the angle. So you have to make sure that you are tightening and losing the exact screws which are necessary for measurement of angle. So don't get confused into this part, and always in the taking the readings you have to make sure that your level tube, your bubble of the instrument is at the center. Again for bisecting you can take the help of this knobs which are provided on the top of the telescope. By using this vertical tangent screw you can also adjust your telescope. So this method is used generally for measurement of included angle between two points. So by taking the repetition we are neglecting the errors, we are reducing the errors. So for error distribution we can use this method. In this we have used the face left condition, you can use face right condition also if you want to measure the readings. You can use clockwise direction, you can use anti-clockwise direction also. Now we will see how to calculate the included angle by our readings.
So these are the readings which we have taken on the ground for measurement of horizontal angle by using the theodolite. So we are using repetition method. So in repetition method, as we know that we have to take two conditions, face left condition and face right condition. So these are some readings which we have observed by using face left condition. So these are some instrumentations. So P and Q are the reading stations. Then for vernier A and in vernier B, we have observed these angles, that is these values. So these values are written in the degree, minutes and seconds. So you have to just plot the answers in the observation table, and in the last simply you have to take the mean angle of different observations, and in the last you have to take average of these three observations. So our included angle for point PQ, by taking the mean of these readings, so we have find out the angle as 30 degree, 10 minutes and 15 seconds. So this is our included angle which we have find out by using the repetition.